Okay. So we are going to see some interesting codes, some important things which we require sometimes in Python. So I just named the notebook as interesting codes. Okay. So first we'll see the calendar. This is required, date, time, and all are required. So import calendar, and then you just have to give the month and all, and print year. This is inbuilt with collapse, so I don't have to worry about that. And month, let's say 4. If I want to see the calendar of this month, all I have to do is print calendar, and then I have to pick a month also, and y mm should be enough. You just have to display the, let's put it, display the specific month of a, oh, I forgot F. So let's run it and see if we can get the calendar for this month. I hope I'm not muted myself. Okay, so we have April 22, 2022, and we have the calendar in front of us. So this you can use, and for the year also we can generate. We have already imported calendar, so just have to see and how we can extract the things I'll tell you. And let me share this link first, where you can get the documentation of calendar. Okay, just put it here. Very simple things, but important. Okay, so this is the documentation where you can get more details, and let's see some examples. And now I want to print the calendar for this year, and okay, can have print calendar dot calendar and 2022. Now we have to give the 216, that is multi-line strings. I'll just show you. See, 216. This is how it is divided. So for this year, we have the calendar. If you want to have the year for the next year, 23, let's change the year. There you are. And if you want to see the previous years, put the year there. Let's see 1947. 1947, January started with a Wednesday, sorry, not Wednesday, and ended with Wednesday, right? 31. Coincidence or it happens? 47. Let's see this year, what it started, what it ends with. The same. Saturday and ends with a Saturday. Okay. So when you start a year with a week, day it ends with the same. Okay. Leap year and all we'll have to see. Anyway, okay. So we have something else also. We have date time, and We have time delta also. I can, if I want to find all the Sundays of a year, then I can use this code. I'll just paste the things required. That is this one, top, which is already there with me. Now I'll define a function, all Sundays. I just pass the year. Don't give any errors as such. We have t is equal to date, here which we have passed, one, sorry, 1 1. Here, sorry, I need to click this. It has to be a comma. There's one extra bracket here. Here we can integer month and date. 1st January of the year. First day of the year. January 1st. Yes. So t will return that of the year, and then d plus. D is equal to d plus or d plus, equal to time delta we have, yeah, time delta we have to say days is equal to 6 minus d dot minus minus d dot weekday. Okay. That is first, that will get you the first Sunday. Now will get you the first Sunday. Okay. Now I'll d dot year is equal to year. Till the year is same. Column there. Yield d, then yield. I spelled it wrong. D, then d is equal to d plus or d plus equal to same thing. Time, sorry, there is, so here time delta, then we have days minus 7. Days we have, don't have the days. I have the days. Okay. Days equal to 7. Sorry, not minus. Now it will be fine because this is a variable now. Now we have to put a loop for d in all days, and I have to put pass on the year. Let's say 2022. All Sundays. All Sundays. Yes, it is all Sundays. Now it's fine. All I have to do is now to print what I get from the function print d. So all Sundays, go there, find first Sunday you find, and then I keep on adding 7. That's what. See, get all the Sundays of 2022. So you can get all the Sundays this way, or you want to find something else, you can find that we have weekday option there. So you just have to find -6 minus or whatever you want to find, you can find that. You can play around and see of any year you can find. It's not that you have to, you can find for the current year, you can do it for any year. Okay. Now let's play again. We have something interesting. We all have used random, uh, but we'll see a lot of things with random today, what random can do and how random can be used to design small games. And first of all, rock, paper, and scissors. So this is little complicated game. Not complicated. There are two players actually. One is your computer and one you. So who is playing, and then you have to decide actually uh, what the things are. So you need some conditions actually. So you just have to put some condition. You have to import. You have to take the user action, input a choice, and you have to say that. And I'll just that part because you know that I'm a little lazy, so I've already tested the codes. I'm just pasting from there. Okay. User ch twice equal to. Oh, I did not import random, so without that, this is not going to work. I have to import random. Find a choice, rock, paper, scissors. We have played this game so many times, and the possible actions. Action, action rather, not actions. This will be one action only. Either it will be rock or paper. Paper, paper only. Rock, paper, and scissors. Yeah, yeah, it is paper. I never played it. I played the game. Yes, it is not paper. Rock, paper, and scissors. Right. Now it's okay. Okay. And then we have scissors. Oh, I have also played this game. How did I write paper there? Anyway, so rock, paper, paper, and scissor. And now we can compute action. One is we have already taken the action of your from you, that is user. Now we want the choice of the possible actions. Now this random function returns a random choice. Okay? So if you have rock, paper, and scissors, of that randomly it will choose one. So it may be rock, it may be paper, or it may be scissors. Now the game says that if it is same, then it is you have to tell. If both of them choose the same, then you have to tell what the thing is. Like this may be selected the same thing. So you have to say who wins, who loses. So first of all, you have to you choose what did you choose and what did the computer choose. So compute action, I have taken compute action. Compute is computer only. I'll just make it computer so that it looks more decent. And this is user action or user choice. That will be fine. So the choice is what you have already entered, and this is computer action which we have computed. Now we have to get the results. So for the result, so we have to put some if else now. If user choice, that is choice of the user, is equal to the choice of the computer. Computer action and both are same. Okay. Then we print both they selected the same choice. Okay. And so it is a choice. It is a tie. Both they selected use choice, or we can put compute choice also action. So it's a tie. Now else. So we have elif user action, user choice, sorry, choice is equal to rock. So you have chosen rock, and computer has chosen scissors. If computer action is equal to scissors, we have to put all the possible combinations. So you can put something like this. Rock smashes is a U smashed the computer. We have some decorations. U. Okay. One action. In this also we have other options. Else have when either you lose or you win. Okay, so rock is already taken. Now scissors we have checked. We have to see the paper. So if you do this, else you'll lose, no? Otherwise it will be paper. Not same. So we have been thrashed. You are smashed by the computer. This means that rock lose. Paper covers rock. Okay, you lose. You are not smashed, covered. You can design your own statements. Okay, so now if I have to check the other one, user action, user choice, sorry, user choice equal to paper. Now it is paper, and if computer action is equal to wrong, we're wrong. Mhm. If it is paper and the okay, your choice is paper, so you're still safe. Let me copy this to cover the computer. You win. Statements are your choice. Now else, you'll be losing. That means cut. It is a scissor. When you are cut by the computer, you lose. Okay. So we have seen rock, paper, and now suppose you choose scissors. User choice. Sorry. Choice. Okay. That's equal to scissors. You guys can use it similar thing for a lot for the uh, codes you can generate, the random codes and all. I'll show you some more. Now, if computer action is equal to paper, what will be paper? Oh, rock. It will be either rock or the scissors. So if it is paper, action, there is something wrong. Now, just start to print. That scissors cut, you cut computer. You cut computer, you win, otherwise you lose. Either you win or either you lose. Uh, rock, yeah, smashed by the because it would be a rock. You lose. You save it. Okay. So if there is no typo errors, this code should work. I hope I have not done any typing mistakes because I can't see any reds there. Yeah. So I choose rock. Okay. There is something wrong. Choice. See? No, 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 no. Yes. I told you some typo errors can be there. Okay, now I can run it again. So I'll choose rock. I lose. Oh, I have been covered. It chose paper. I thought the rock cannot lose. Okay, it can. So paper covers the rock and you lose. I was trying to play smart, but my computer was smarter. Anyway, so you can design this game rock, paper, scissors, something like this, or you can use the random to do something else also. And we'll have a look at some more randoms, what random can do. Because random is something which is very important, and when we are doing deep learning, machine learning, they're all randomly generating the values, and we normally fix that by using seed, random seed, and we fix it to a certain value so that we get the repeated results, but we are not doing it here. So random is something which is very important as far as coding is concerned, whether you are doing AI or whatever you are doing, random is always there. Either it is working in background or otherwise. Okay, so let's see. So we have one more example shuffling of a cards. I have not put. I've just copy paste. I'll just put a few cards here. Ace, two, three, four. I can increase that. I can have a king. I can have a queen. I can have a jack. That is okay. And one is missing. One is what? One is already there. Yes. Okay. And two, three, four, and you can go on. 5, 6, 7, 8, 9, 10 we have. Okay. Jack is there. So 10 is also there. Okay. So this is only for one color. Any of the color. Just attack with some cards, and we use shuffle command here. Shuffle a list, and we can print the deck now. I'll just run the command. Not put, you can see this. Now it is shuffled, randomly shuffled, and now you get different results. Okay, this is shuffling, if you have played cards, so you can shuffle the cards like this. We can make it more elaborate by having your colors. Okay, you can have the spade, knights. You can do whatever the colors are. Clubs, club is there, heart is there. Then we have what, brick or something like that. I just diamond. Sorry. Okay, so random, actually what random does is if I do random and random only directly, it will just give me a number, a random number which will be a float value, a double value you can say. So it will change every time I'll run. Now if I want to use this and I want to play truth and dare, very simple game. I don't have to rotate the bottle. I can simply use this and play. So I'll say game is equal to uh, two things. One is truth, one is dare, and random dot choice. So just run it now. What I get? I get truth. Okay, so I have to tell the truth. I'm not telling you. Okay, there I can do that. I can feel everyone. I won't do that also. Anyway, so you can use this game. You can have truth and dare something, and it's only that when we are in a group, then you have a bottle because you just want to rotate and tell what you have to do. That's all. Wherever it is pointing, but that also can be designed actually, and you just have to be more innovative. Like we can have rolling dice, so we can have something like rolling dice, up the things and choose the number of the person. So if you don't have anything, you can use your games like this. And we have a dice which is having number. You can have two dice also. One, two, three, four, five, and six. These are the numbers which are there on the dice. And if I random dot choice of the dice, I'll get six. Good. Okay, man, not bad. So rolling a dice, you can roll a dice, you can club the things and see. So random dot choice is something very interesting which we can use to do a few things, right? So this is about random and the calendar, two things we have done, and we are going to add few more things. I'm telling you something interesting again now, and this is can be more relevant actually. I'll be doing image object detection. Image. I have an image, so I'll be using object detection, and I'll explain it how it is done. It can be useful because if you're using robotics, so if you're going for robotics, or if you're designing anything in a machine which vision with a vision, so it will be very useful. Okay, so we can use that because now what we have these days are the only, we have only the systems. You have the cameras, we cannot actually detect, we can detect the faces but we cannot detect anything else. So no warnings, nothing. So what is the point of having a camera if it cannot actually identify the thing, what is the action going on? Okay, so anyway, so we'll have a few installations here, and this is very important because I had to apply a few of my time, some of my time, sorry, and my brains also to get to the working model. Because when the problem with Python is when it upgrades, so the things change and the latest versions may not be having the same functionality or the function changes. So we have a module called image AI. AI is artificial intelligence, we know that. So we have a module like this, but if I install it as it is, so it doesn't work. So I have to upgrade that. Although it should be installing the latest version, but somehow if I use upgrade, then it gives me the required attached modules also with it. Now TensorFlow by default is if I install TensorFlow, it is 2.8 version, but I need 2.7 version because the code I'm going to use does not work on 2.8. That is another issue. Okay, but something is working, we use it. Okay, so I had to figure out. It took me a little time to figure out the things, but it works. Then again, I have to install Keras, although it is there, but again, I have to install it. Then only it is going to work. So I have to install three things. One is ImageAI, the other is TensorFlow 2.7, and ImageAI also has to be upgraded. And then we need the Keras. So Keras by default may be there, but we have to get this now. So let's run the things. It will take little time, not much, but it will. It may say that already satisfied. I installed it yesterday, but I closed. So anyway, let's see what all is required will be installed. Whatever is already there will be ignored. So if something is missing, that will be installed. If something is already there, it will be ignored. See, you can see that it is uninstalling 2.8.0 because I'm on 2.7. They give me some warnings also, errors also, but at the end of the day, it is installed. You can see successfully installed. Now I have the environment set, and what I have to do is we have an image which is to be put, and then we are using YOLO tiny uh, classifier. Okay, you see only once, you look at only once is what YOLO is. Okay, so I'll have to make a few things here. One is the image. I've already done it, so I'm just pasting it. So from image AI dot detection, import object detection. Okay, the detector, we have to create an object. Create an object. Create an object of the detector. So we have just object detector detection we have created. Now YOLO Tiny H5, I have to install it. Upload it here. Let me see if I can find here only. I think it was there somewhere. So it's there on my drive. I downloaded that yesterday. Okay, you won't be able to see what I'm doing, but I'm actually browsing through. Yes, I found it. Folders to get this remind upload files will be deleted. Recycle runtime recycle. That is why we use mount, but I've not used mount here. I could have used mount and put everything there, but I wanted to just install the things and show you what is there. And I would be requiring folders like input and output folders, so to store the file. I don't need it actually. I can just put it like that. I would be requiring one more, so I don't put it in a folder. I can just I want to put it in a folder. Input path, model path. We need the model path. Now this before it will take little time for tiny YOLO tiny to install. It is tiny. You just believe me, it is tiny. This is basically a classifier. More or less, they're the most common, you can say, classifier is your hard classifier. Now, what is a classifier? Basically, classifier is optimized to find objects in an image. Now, how it finds, actually, that is interesting. And what it has that that helps the classifiers to find an object. Suppose we have car. So whatever the parameters of the car are, like the height, the width, the tires, screen, the lights, okay, back lights and the front lights, doors and all, that will be actually the features which will be there. And the classifier would be having the details. But then the question comes that it varies. The cars vary. Okay, so they may be having different colors. They may be having different shape, length. Sorry, not the shape. Shape will be still the almost the same, but length can be different. Height can be different. Okay, so in that case, actually, it has the details of the uh, maximum possibilities, you can say, of a car. Okay, so we have that now. If it is a bus, it will again have the maximum possibilities. We have a huge data set of buses, double-decker buses also, and other buses also. From there, it extracts the features and stores. So I don't have to create that. I can do it. What I can do is I can create the. I can get all the images of the buses. I can get the features done and store them, and then use it. But then it will be only specific to the buses. It won't be able to detect anything else, right? So if you have clubbed everything, the vehicles, you can detect the vehicles. Now, this classifier actually is not limited to vehicles only. This classifier is actually is having lot of details. That is why you can see that the image is very, sorry, the file is big. This is a huge coding actually. And once I opened the hard classifier, I took some printouts, and I stopped it at 50, but it was having huge 50 pages. It was having a lot of pages, so I just had 50 pages to understand what the classifier is doing. And this is similar classifier, so it will also be having a lot of code in it. And the code is all about dimensions, basically, of the things. If we say car, then all the possible dimensions, mathematically written things, not the images, right? And not the features. It is basically, if you find something in an image, then you just have to get the dimensions. And how it finds, basically, there is something called background subtraction. First of all, you have to remove the background, and then whatever is highlighted, that you can actually find, think it as an object. And from where it changes, the color changes till where it varies, or the uh, it not even the color actually, because we are using, when we dilate the image, when we remove the background, uh, the huge image processing. DIP is interesting, image processing is interesting, but anyway, I cannot take all that. I'm just giving you a few hints on it, that when it removes the background and all, and it finds something which is not there in the not matching, because obviously when we remove the background, only the objects remain. Okay, so it can move around and see where there's a drastic change in the colors, because image is nothing but pixel of colors. It is colors only, and in our case, it is only a number. So a number is there. So it is able to detect that it has person also, it has actions also, the classifier. So it can detect, the classifiers can detect a lot of things. We are using YOLO. Okay, this is a YOLO classifier, which is relatively new. Normally with OpenCV, we use R classifier. That is more common. But over the years, things change, so we are using YOLO, and there are different versions of YOLO. And you can see .h5 that tells me that it is a classifier. This will be XML code, I think. Should be as XML. You can open it and see. I will be uploading this also on the GitHub library. Sorry, GitHub. Yeah, library. Repository, sorry, not library. And okay, so why classifier is installed? That was something which was the lengthiest part. And now we'll have to share the classifier. Otherwise, you won't be able to work on it. Okay, now let me find the image I have used. Basically, this image was already there in the example, so I've used the same image, but you can change the image and use your image and see if it can recognize or not. So this image was a traffic image, so I've named it as test traffic. I'll be uploading that also, sharing that also. Okay, so what test traffic we have, then output is new image, what we are going to do, and let me run it and see if it works. If it works, then it can actually, I can go ahead and do the things. Now I'm ready. Okay, I'm ready now. I can code further and get the things done. So I need a detector and set the model type as tiny YOLO version 3. And then we have to set the model path and load the model. Okay, two things, just a few lines we have to do. So we can have detector is already there. Detector, I normally don't type detector, yeah, dot. Okay. We need set dot set should come. Okay, here this one. I need YOLO version 3. This type as tiny YOLO, or I need a tiny YOLO. Or dot set I need tiny YOLO because I've used tiny YOLO, so I need tiny YOLO only as a function. So just have to put the brackets. Now detector dot again set. Oh, sorry, detector dot set model path. I have to set model path. Model path is the path which we are going to give basically where the model is. So we have put already model path. Model path is just the name of the classifier where your classifier is. And then we have to load the model detector. It is set that what is the classifier we are going to use and the where the classifier is dot load. We have load detector dot load model. We have load model. So we are doing this. We are just loading that, and now detection. All you have to do is now detect. Detection is equal to, we have the detector, detector, sorry, dot detector dot. We have to detect object from image. Okay. Dot detector dot detect object from image. Here you are. Objects from image. Object or objects. Okay. So we are detecting objects. Now Here we have input image. This is what you have to give. Input image is equal to path. I could have given the image here also, not an issue. And I have to give the output also. Out image path equal to output. That's all. Now, this is done. Now what you have to do is you have to mark the objects which we are detecting. And traffic image I can show you. First, let's see the traffic image. This is the image of the traffic, not of India, it's somewhere else. So that was there in the example. I've used the same thing. So we have a lot of things here. Doesn't look like India, but the vehicles are more close to the vehicles. Not easy to find. You have to see the number plate, or number plate doesn't look India. Anyway, doesn't matter. Wherever it is, you can see this. So this is the image we have. The buildings are there. The traffic is there. Okay. Now we have to put a loop to mark all the objects. Okay. For each item, uh, it is all already detected. I'm just displaying that. Each item in detection. Just have to put what we have detected. We are just displaying. We have to print. I just paste. I'm not going to waste my time. This just explain. Okay. Each item name and percentage probability. What is the probability that it has been detected or it is the correct detection? Right. So just a few lines of code. We have to import image AI detection, then detector, create an object, then you have to call your classifier, then image, and the new image where you want to save your file to, and then detector. You have to call the, you have to set it to model tiny model YOLO version 3. We have other versions also. Then detector set model path, and to model path which we have already given, that is the traffic test traffic image, then load the model, then detect. Simple. Detection is going to detector dot detect custom objects from image. Custom objects. It is not custom objects, it is objects. That is what I was wondering. Now this is fine. Yeah, not custom. Custom is I have to give already. So everything works fine. So it should be able to detect, and my image I have already displayed. So there's something wrong in this list. Object is not callable. Okay. So I have done something wrong here. Let me paste it again. I'll just paste the things. Some typing errors go. So it happens. Image input path, output image, or path is output path, detection is fine. It should be okay. Detection is fine. Yeah. So you can see that it has car, bus, car, person, probability you can see in the car and all. So bus is also there, but let's see what it has detected. So we'll just show the image. So we have to import CV2. I'm just importing CV2. I need actually Google Colab patches CV2 image show. This is the original image I'm trying to show you. Okay, so this is the original image. I can paste that same code and now input and the output. I have to give that output path of input, output path, and I just change that image out something else so that I still have the original image with me. let's see what it has detected. See, now I'll just show you something interesting which is not correct. It has detected the person perfectly fine, detecting an auto as a bus because it is not a car, and it may not be, the classifier may not be having uh, classification uh, for an auto, because this is not very common. It may be from India or maybe Asia somewhere that you find this kind of auto, maybe Kolkata. So because they have some blue autos or somewhere, I have not seen actually. Maybe Pune also, but it is doesn't look like Pune to me. But somewhere anyway, it may not be India at all. So whatever it is, you can see that it has detected the cars perfectly, and the percentage is there: 98, 99, 89, and 59. There's overlapping of the cars. That is possible. Only part of it you can see that. So you can actually detect the objects, and once it is detected, you can see that what it has returned, and you can have a look at the detection. And I can detection, I can just display detection and see what, and show you it has. This could be important. See, we have the name, percentage, probability, box points. Okay, box points are there. So from the boxes, basically, we get the object. This is the dimension of an image. Now, what normally I do, or I recommend my students in DIP to plot or the print the image on a graph paper. So, if you print your image on a graph paper, you will find the coordinates, the dimensions you can easily make out. So although the dimensions could be different, but this may be a big image, and you can get a smaller image, but you will be able to understand the coordinates, the image size. Like this corner, there are four corners, and these are the four values you get: 815, 408, 1013, and 536. This is the dimension of the image of the box it has actually created around it. So automatically it is done. So you're not doing anything. But from there, if you have this dimension, what you can do it, you can simply segment using this. You just retain this and just remove everything, because you have now the coordinates. You can remove everything, and you will have only the required thing. And if it is a car, and the dimensions are there, you can simply remove everything else and retain only the car. Okay, only one car if you want, you can do that also. So it all depends. Like, you can see the probability. If it is more than 80%, you can just segment it. So image segmented, that is a part of DIP. I could have taken it, but it is not part of it. So it's just out of bounds actually for now. But anyway, I've taken it because it was important, and for if you're designing some machines, or if you're designing robotics and all, even if for the cars, vehicles, this detection is interesting and important also. So you can detect the image, you can detect a person, and from a CCTV camera, if you're designing, you can detect the things easily, and that can be done. I normally use uh, MATLAB to do this, but you can use Python CV, OpenCV, okay, also, or you can use the other classifier, Image AI. This is Image AI. Otherwise, you can use OpenCV also to detect objects, right? But anyway, that has to be explored, and that you can explore later. And for now, this you can practice few things. You have now the randoms you have to play the games. Not only games, actually. The calendar you have the random numbers. Random is everywhere in coding. So in machine learning and AI, you will find random everywhere. So it is important thing, right? So you guys can have a look at it and practice it so that you can